Hello, lovely people. Let's solve for x. First, let's divide through by x root of 36, okay? So, divided by x root of 36, divided by x root of 36, divided by x root of 36. Now, when this divides itself, we have 1. Now, for this, when you have nth root of A divided by nth root of B. This is equal to nth root of A divided by B. So we are going to use this to write this and this, okay? Or we are going to write this and this in this form. So we are going to have, when this divide itself, we have 1 plus. Now this is going to be x root of 24 divided by 36 is equal to, this will be x root of 16 divided by 36. Now we have 1 plus x root of, now this 24, the highest common factor of 24 and 36 is 12. 24 divided by 12 is 2. 36 divided by 12 is 3. Is equal to the x root of, the highest common factor of this and this is 4. 16 divided by 4 is 4. 36 divided by 4 will give us 9. All right. Now, we have 1 plus x root of 2 over 3 is equal to x root of 4 is same thing as 2 squared and 9 is same thing as 3 squared. So we can write 1 plus x root of 2 over 3 is equal to x root of 2 over 3 raised to the power of 2, since they share the same power. All right. Okay. Now note that nth root of a is equal to a to the power of 1 over n. So that means we can write this as 1 plus 2 over 3 to the power of 1 over x is equal to 2 over 3 squared to the power of 1 over x as well. Now, if this is the first time you're coming across this channel, please click on the subscription button, turn on the notification bell so that you don't miss our amazing videos. We upload videos daily, so please tune in at your convenience to watch our new uploads. Thank you very much. Now, let's continue. We have 1 plus 2 over 3 to the power of 1 over x is equal to, now when you have a to the power of m raised to the power of n, this can be written as a to the power of n raised to the power of m, okay? So that means that we can write this as 2 over 3 raised to the power of 1 over x raised to the power of 2. All right. Now you can see that we have 2 over 3 to the power of 1 over x, 2 over 3 to the power of 1 over x. Now we can say let 2 over 3 to the power of 1 over x be equal to y. Now if we make that statement, that means we can write 1 plus y is equal to y squared. So let's transfer this to this side because we just formed a quadratic equation. So we can write this as y squared plus y will cross to become minus y, and plus 1 will cross to become minus 1 is equal to 0. Now, we are going to solve this quadratic equation using the quadratic equation formula. Now, the quadratic equation formula states that this y will be equal to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. So we can now write from here our a is equal to 1, that is coefficient of y squared. Then our b is minus 1, which is the coefficient of y, and our c is our constant, which is also minus 1. Now let's substitute the whole of this into this particular equation. Now the quadratic equation states that y is equal to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. So our y is equal to minus, remember that our b is minus 1, plus or minus square root of minus 1 squared minus 4ac, 4 multiplied by our a is 1 while our c is minus 1. Okay, everything divided by 2a, that is 2 multiplied by 1. So we have y is equal to minus times minus is plus, so we are going to have 1 plus or minus square root of minus 1 squared is 1 minus 4 times 1 times minus 1 will give us minus 4 divided by 2 times 1, which is 2. So we have that y is equal to 1 plus or minus square root of 1 minus minus is plus, so we have 1 plus 4 divided by 2. So y is equal to 1 plus or minus root 5 divided by 2. So we have two values for our y. Our y is 1 plus root 5 divided by 2, or y is equal to 1 minus root 5 divided by 2. Okay, now because we are looking for the value of x, and when you look at it, this is where we are going to get our x from. All right, this is 2 over 3 raised to the power of 1 over x. Since our x is part of the power, we can only solve this using logarithm, and there is no logarithm of a negative number, right? So if you look at this, notice that when we solve this, we get a negative number, so this is rejected. The second one rejected, and that is because there is no logarithm of a negative number. So this is what we are going to use to find our x. Now recall that y is equal to 2 over 3 to the power of 1 over x. So we have that y is equal to 1 plus root 5 over 2. Recall that y is equal to 2 over 3 to the power of 1 over x. Okay, all right, so we can now write 2 over 3 raised to the power of 1 over x is equal to 1 plus root 5 divided by 2. So we are going to introduce log, just like I said. So let's introduce log to both sides of this equation. So we have log 2 over 3 to the power of 1 over x is equal to log 1 plus root 5 divided by 2. All right, now when you have log a raised to the power of b is actually equal to b multiplied by log a. So that means that we can write this as 1 over x multiplied by log 2 over 3, okay, is equal to log 1 plus root 5 divided by 2. Okay, now note that when you have log a over b is actually equal to log a minus log b. Okay, so but before that, let's get 1 over x. So to get 1 over x, we need to divide both sides of this equation by log 2 over 3. So we are going to have 1 over x is equal to log 1 plus root 5 divided by 2. All right, everything over log 2 over 3. Now we are going to apply this law here. So we have 1 over x is equal to log, so this is going to be log 1 plus root 5 minus log 2, that is for the numerator, divided by log 2 minus log 3 for the denominator. So we have 1 over x is equal to, sorry, since you are looking for x, you are not going to take the reciprocal of this side. So it simply means that our x is equal to log 2 minus log 3 divided by log 1 plus root 5 minus log 2. Okay, so we go ahead and solve. X is equal to log 2 is same thing as 0.3010, then log 3 is same thing as 0.477 divided by, now log 1 plus root 5 will give us 0.510 minus log 2, which is 0.3010. Okay, now x is equal to, if we solve the numerator, we are going to have minus 0.